What I'd like to do in this video is lay out in one quick table information on solubility trends that covers several slides. We'll look at the effect of both temperature and pressure on solubility in different situations, one when you're dissolving a solid, the other when you're dissolving a gas. You guys probably have a good idea of what happens when you raise the temperature and what effect that has on the solubility of a solid. Yeah, it's a lot easier to dissolve sugar or salt. You've done this in your own kitchen when it's a higher temperature. So the solubility goes up when the temperature is going up. There's a couple cool videos in the slides of sodium acetate crystallizing out of solution because it becomes colder and less sodium acetate is allowed to be dissolved. The same thing can happen with sugar. If you've ever had rock candy or maybe even tried to make it, what happens, what you do first is you boil some water, dissolve a lot of sugar in there, maybe some corn syrup, and then let it get cooler. And as it cools off, the solubility decreases and some of that sugar crystallizes out of the solution. So that's pretty straightforward, but the effect of temperature on gas solubility is totally the opposite. If you want to dissolve more gas, you make it colder. And you may already know this if you like to drink carbonated beverages. If you want to keep the carbon dioxide dissolved in the beverage, then you keep it cold. This is why you put it in the fridge. And think about this question: why is it that during the hot, sunny summer day, you want to drop your fishing line toward the bottom of the lake? Thinking about it, processing, thinking. Alright, so the sun hits the top of the lake. A lot of the sunlight gets absorbed near the top, especially if it's murky water. The top's going to heat up pretty well. Also, hot water rises because it's less dense. So it's going to be cooler on the bottom. That means there's going to be a higher solubility of gas in the cooler water on the bottom, gases including oxygen, which fish need. They breathe oxygen through their gills too. So the fish, they're going to get more oxygen at the lower, colder depths. All right, now let's look at the effect of pressure on solubility of solids. Have you ever tried to dissolve more sugar or salt by increasing the pressure? Neither have I, because it doesn't work. It's not a thing because the pressure actually has no effect. But what about on a gas? That's a totally different story. If you're trying to dissolve a gas in a liquid, you can kind of think about it as if you're squeezing the gas into the liquid at higher pressure. And again, we can think about your carbonated beverage, your Coca-Cola or whatever. Putting it in the refrigerator is only half the battle. You got to put the cap on, in order to keep the pressure in. You got to let the pressure build up in there, and then that high pressure will keep more carbon dioxide from coming out of the solution. Another situation where this is important is inside our bodies. Air is 80% nitrogen, and so is the gas in the scuba tanks. And when people go, scuba diving and they go significantly deep underwater, the pressure on them increases significantly. Every 10 meters of water is equivalent to an atmosphere pressure. So if they go down a ways, that increased pressure is increasing the solubility of nitrogen in the solution that we call their blood. So they get more nitrogen dissolved in their blood. And what can happen if they come back up too fast is the pressure decreases too fast, the solubility of nitrogen decreases too fast, and the nitrogen comes out of the solution as gas bubbles. And I kind of imagine this as, like bubbles of nitrogen going through your veins, like in the horror movies with like roaches going through somebody's bloodstream. But this is what's called the bends. If you go up too fast and nitrogen comes out of your bloodstream as a gas, it can damage organs. It doesn't feel good. It's not fun, and this is why they have hyperbaric chambers. So if you do get the bends, they can put you in a high pressure chamber that kind of increases the solubility of gases, including nitrogen, and kind of forces them back into your blood, or um, lets the nitrogen come out of your blood more slowly. So the idea when you're scuba diving is to come up slowly from the depths, to let the nitrogen slowly come out of the solution of your blood